Okay, so in the previous couple of videos, we learnt what packages were and how to actually use them. And it's now time to actually have a look at scope and also granting or restricting access to our objects. So the thing is with scope, it's probably one of the easiest things about programming once you understand it, but it's actually also one of the most confusing until you do actually understand it. So scope here actually refers to the visibility of a class, member or variable. So to consider that in non-computing terms, let's imagine you're going to buy a particular computer and you find a local store and let's just say it's got the computer for 20% off, 20% discount. Now the same computer in another store would still be at the full price though. So the scope, in other words, of the price reduction is just that one local store. But contrast that to a situation where you've got a large company, and let's use Walmart as an example, huge company in the United States. And let's just say they decided to discount a particular computer. So the discount then would actually apply in about 4,500 stores across America. So in that context, the scope of the discount is therefore much, much wider. And actually, as Walmart is a multinational company, if they applied the discount worldwide, the scope would be over 11,000 stores. So the important thing here is that Walmart's discount does not apply to any other stores. So the scope is limited to the stores controlled only by Walmart. And the same with the local example, the local store that had the 20% off. The scope there is just for that one local store. So the same computer, and in a Java context would be the same variable, in other stores is not discounted. So I hope that makes sense. So our Java objects have got scope in much the same way. So what we're going to do now is code up an example to discuss the scope. We'll show you the scope of various objects to help you sort of understand the scope a little bit better. So we're going to start off by creating a new class. And we're just going to call that scope check. So I'm just going to click on and select a new class. Scope check is the name of it. And what we're going to do is create a few variables. First one, a member variable, public int. We'll call this one public var equals 0. But we'll also have a private int private var equals 1. We'll add a constructor. This constructor won't have any parameters, but what we'll do is we'll actually just print out a message to say that scope check created, and just show the variable value. So public var equals plus public var plus and private var equals plus private var, just to show the values. And we'll also create a getter as well. So we'll need that shortly. And a getter will be just for the private var, like so. So there's our basic scope check. So what we're going to do now is go to the main class and to the main method and check and create a new instance and then check the value of private var in main. So to do that, we're going to go back to main. In here in the main method, we're going to do string private var. Noting the name is the same as it was typed into the scope check. This is private to main. Then we'll create an instance of scope check. So scope check scope instance, doesn't really matter what we call it, equals new scope check. Then we'll just do some output. We'll do, first one we'll put is scope instance private var is scope instance dot get private var using the getter, and then we also want to print out our value for private var. And of course we're noticing that the private var there and private var here are the same named variables, but they're actually separate variables. So we've got two variables called private var. One's the string, which I've defined above in the main method, you can see on the screen, and the other is the int in our scope check object that we created, which is going to be scope instance. Now we can only access the private var in scope instance by using the getter. Again, the getter was what we created here. We can't access that directly, so if we actually run this, unsurprisingly, we get the first one, scope instance private var is 1, and that was called from the constructor. If you recall, we put that message in there. And this is private to main, is the same variable name, but a different variable that is local to the main method. that's got a different value. It's actually a different type. In this case, it's actually a string. So within the main method itself, whenever we refer to private var, Java actually knows that we must be referring to the one declared with main, as that's the only one that's available in the current scope. So in other words, it's referred to, that variable is referred to as being in scope. So access modifiers such as public, private and protected, they're actually one way to restrict the scope of an object, and we'll be looking at these access modifiers in more detail shortly. But as it turns out, scope is even more important within the same class or method. So what we're going to do now is shoot over to scope check, our scope check class, and we're going to create a new method there. And we'll call that one public void times 2. And it's just going to be a simple method that actually prints out some of the 2 times tables. So we're going to start with the definition, private var equals 2. Note the name of the variable and note the fact that on line 8 we've also got a variable with the same name. For int I equals 0, I less than 10, I plus plus. And we're just going to output I plus times 2 is plus I times private var. Very, very simple, as you can see there. So the method, as you can see, as I mentioned, also declares a variable called private var and sets the initial value to 2. So when we use it in the loop, I is multiplied by the value of this one, of this variable here, and not this variable here. And that's because private var that's actually local to this method is actually in scope. So just to confirm that actually is the case, we're going to go back to our main method. And let's actually just print that out, or just run this method. So scope instance dot times 2. So if you run that, we should actually confirm that that's working. 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, and so on. So it's clearly multiplying by 2. And if we go back and actually look at our code, we've got this line here on line 19, setting the local variable private var to 2. And obviously, if Java wasn't reading that, it would be coming back up here and looking for private var, which is have the value 1. So you can actually see that in our example, it clearly did work. It multiplied by 2. So by declaring that private var again inside the times 2 method, we created a new variable whose scope is the current method. So anytime we refer to private var inside the 2 times method, we're now actually referring to the variable within the most local scope. So although they've got the same name, the rules of scope ensure that the variable with the narrowest scope is the one that is used. Narrowest being the one that's most local. So in this case, private var in the times 2 method. So another way to consider this is to use the concept of enclosing blocks. So when Java sees a reference to a variable, what it does, it starts by checking the current block of code to see if the variable was actually declared there. Now, if it is declared there, then that variable is used. But if there's no such declaration and it's not there, then Java actually checks any block that encloses the current one to see if there's a declaration there. So it keeps doing this, working backwards until it finds the variable declaration. And if it doesn't actually find one, then you actually get an error in your code. And of course, the code won't be able to run because the variable won't be found. So in this times 2 example, there's no declaration of private var within the current block. So the current block being the for loop I'm talking about. So there's no declaration in there. So Java actually checks the enclosing block, which is the method itself. So this would be the current block, the block in braces for the for loop. And obviously where the brace starts and ends, that group of code, there's no private variable defined. There's no variable with that name defined. So it then takes it out to the next level, which is the next enclosing block, which in this case is the entire method. And it does actually find the variable private var, and that's why it's able to use it, because that's the next most local one. Now there's 2 variables, as you can see, within this for loop that are actually being used. We've got private var that we've discussed just now, and also I. So I is actually declared in the for loop. So here, in this loop here, it's actually defined. It's actually in that loop, so it's in that scope. The scope of the 2 braces, in other words. So the scope is limited to that block plus any contained block if there were any, in which there isn't in this case. So to check that, we can actually try doing this and we should get an error. So if we try to do something like value of I is now plus I, we're immediately going to get an error. And as you can see, it's in red. IntelliJ is actually showing there's an error because it cannot resolve the symbol I. And if we actually tried to run it, we'd actually get the same error as well. And that's because I is declared in the for loop, but its scope is actually restricted to within that loop, and it's not actually available outside of that loop. So as soon as the loop terminates, in other words, as soon as it actually finishes off, 9 times 2 is 18. So once it's done that, and it has exited that block of code, effectively, that's it. The variable I then goes out of scope. So just to confirm again with the scope, so what we'll do now is we'll just comment this line out because we don't need it because it's not going to work. And if I was to comment this line out here, the private var equals 2, which is the local variable we introduced for the times2 method, obviously we haven't got an error, and the reason now is what's happening is Java has looked at that and determined there's no local variable and kept looking above, sort of expanding its search, and it's found this private var in the scope check as a member variable. So if we run this now, even though it says times2, that's because we've actually typed that times2. But you can see the calculations clearly are now multiplying by 1. So it's actually using the value of private var, the member variable on line 8, instead of the local variable that we defined on line 19. So we'll just uncomment that again. So it's actually working. And obviously if we run it again, we now get the correct answers again. Now note here in this situation that the class field, private var with the value 1, still exists and it retains its value, and it can actually be used outside of the 2x method. And as it turns out, we can actually even use it within the 2x method, even if we've also got a variable of the same name. And what we have to do in that scenario is we need to tell Java that we want to use that private var rather than the local one. So what we do is we do that by qualifying the variable name with this. So in other words, if we did specifically, you had this variable on line 19, int private var equals 2, but you specifically wanted to use this variable that we defined at class level, then we could do that. We could change this, and we just actually type the word this dot in front of private var, and that actually tells Java, use this variable on line 8, even if you've got a variable of the same name in scope effectively. And you've seen that in the course a lot of times with getters and setters when we refer to this dot field name to actually specify the field. And obviously if we run that, we're back to multiplying by 1 again, and that's because we've used the this dot, and Java knows then what we're actually talking about, this variable on line 8. And incidentally, if I commented that out, we then get an error. This dot private error doesn't exist anymore, because as far as Java is concerned, you've told it to look for a field in this class or the name of private var, and there's no longer one because we've commented it out. So I'll just undo that again. I'll just set this back to what it was as well. Now the concept of scope doesn't just apply to variables. Methods also have scope as do classes. Class scope can be a little bit confusing, but let's actually start by adding an inner class to our scope check class and have a look at what it does to the scope of things. So I'm going to come down here at the bottom of scope check and add an inner class. So I'm going to call that public class, and we'll call this one inner class. And let's set up a public variable, public int private var, and so on at the value of 3, so it's distinct from anywhere else. We'll create a constructor, and we'll just do a simple output inner class created private var is plus private var, and let's also add exactly the same method we had there, the times2 method. And I'm going to paste that down here again as a method for inner class, and I'll just delete that. It's a little bit confusing with that now. I've commented that out, so I'm going to delete that there as well, making sure that I haven't got this specified anymore in either of the times2 methods. And what we want to do then is create an instance of this inner class, and we'll go back to do that in the main. And we do that using that slightly odd syntax we covered previously, in previous videos for inner classes. So we scope check dot inner class equals scope instance dot new inner class. Like so. I know that's a weird syntax, but we have talked about that in previous videos. And let's now run that code, inner class dot times2, and just if we run that, and what we'll do here is we'll actually put some exclamation, some asterisks here just to make it clear, and we actually run this. You can see the inner class was created and we've got the same calculations happening. So that's all working fine. So once again, getting back to the code, the rule of scope applies, and because private var is declared as a field of the inner class, in this case here now we're talking, and actually what I'll do here just to make this clear is I'll actually delete this declaration here. That's actually what I wanted to do. So that's in the times2 method for inner class, I'm actually deleting the private var. We've run that. This is what I actually wanted to show you. So in this case, what's happening? Well, previously when I had the local variable in there, it used that. But as soon as I've actually deleted that, of course, the scope, the Java is going back checking what the scope is, and it comes back and finds private var, which is defined here in the inner class as the field, and it's using the 3 for calculations, as you can see there, 3, 6, 9, 12, 15, etc. So in this case with the inner class, this definition here, public int private var equals 3, still overrides the private int private var, which is in our scope check class. And just out of interest, it doesn't actually shadow the private var and scope check times 2. So in this first one here at all, those two blocks are not enclosed by or enclosing each other, so there's no actual possibility of either variable being in scope in the other method. And once again, we can actually comment this out if we wanted to here. We don't get an error, so you can see there, and now if we run it again, we're getting the calculations multiplied by 1. So what's happening again is it's looking for a private var, can't find it in the inner class, or couldn't find it within as a local variable in the times 2 method. So it's come up here to private var in scope check and to retrieve the value of 1, and our calculations actually use that again. Now if we actually came back here to times 2 within the inner class and we use this, we actually get an error, and that's because it's looking for the field in inner class. Now obviously that hasn't got a value because it hasn't been defined within inner class. So what we can do then is in that example, we can type scope check.this.private var, which confirms that this is the variable up here that we're actually talking about. You can run that and you can see that's calculating correctly based on the value of 1. But then if we actually uncommented this out again, so we now have got a field in the inner class called private var. If we run this, we're still getting the same calculations based on 1 multiplying by 1, because that variable has been defined in scope check, and because we've used the name of the class .this.private var. So we've explicitly said use this field in the scope check class. And then just out of interest, in the times 2 method, we could use scope as well. We could actually, if we wanted to actually call the times 2 method, we could do scope check .this.times2 if we wanted to specifically call that method that is a method in the scope check class itself. So what I'm going to do is actually finish this video here now. It's getting a little bit long. In the next video, we're just going to finish off a few little minor things to do with scope. We're going to talk a bit more about visibility, and then we're going to start on a challenge. So I'll see you in the next video.